Hi everyone, welcome to our presentation. Today we are going to discuss a topic entitled Supervised Learning, Teaching Computers to Learn from Labeled Data. Before we begin, let us first introduce ourselves. My name is Dia Zafira and my student ID number is 26022202545.
Hello everyone, my name is Elita Camelia and my student ID number is 26021982213 and I am an information system student.
Hello everyone, my name is Kanisa Anjani Santoso and my student ID number is 26021999304. I'm an information system student.
Now, let's begin with the learning outcomes of this presentation. By the end of this presentation, we will able to first, define supervised learning and explain how it works. 2. Differentiate between regression and classification tests. 3. Identify the main algorithm categories in supervised learning. 4. Understand key evaluation metrics used to measure model performance. And the last 5. Recognize real-world application including complaint classification from social media. First, define supervised learning and explain how it works. First, let us understand what supervised learning is. Supervised learning is a machine learning approach in which a model learns from labeled data. In other words, every training example consists of input data together with its correct output or target value. Here, X represents the input features, while Y represents the target label. During the training process, the algorithm learns the relation between X and Y and creates a predictive model, which can be represented as f of X. Once the model has been trained, it can be prediction on new and unseen data. These predictions are represented by hat, which indicates the model estimate output. Overall, the process of supervised learning involves training the model using labeled example, evaluating its performance, and refining it to improve prediction accuracy. Differentiate between regression and classification tests. Next, supervised learning problems are generally divided into two categories, regression and classification. Regression is used when the target output is a continuous numerical value. For example, it can be used to predict house price, sales revenue, or temperature. Meanwhile, classification is used when the output consists of categories or labels. Examples include determining whether an email is spam or identifying the category of a customer complaint. Although both regression and classification use labeled data for training, they differ in the type of output they produce. Regression generates numerical values, whereas classification produces discrete categories or labels. Furthermore, the evaluation metric used to assess these two tasks are also different. That concludes the explanation of the first two learning outcomes. Next, we will move on the main algorithm categories used in supervised learning. Next learning outcomes will be explained by Elita Camelia.
Okay, thank you Dia. There are many supervised learning algorithms available today, but most of them can be grouped into several major categories based on how they learn from data and make predictions. The first category is linear models, such as linear regression and logistic regression. And this algorithm assumes a relatively simple relationship between the input features and the target variable. The main advantage is interpretability, so we can easily understand how each feature contributes to the predictions. And because of their simplicity, linear models are often used as baseline models and remain widely applied in both industry and research. The second category is tree-based models, which include decision tree and random forest. Rather than learning a mathematical equation, these models learn a series of decision rules directly from data. They are capable of capturing more complex relationships and interaction between features, making them suitable for a wide range of both classification and regression tasks. The third category is super vector machine or SVM, and this algorithm works by finding the optimal boundary that separates different classes in the feature space. SVM are particularly effective when dealing with high-dimensional data where the number of features can be very large. And because of this characteristic, they have been widely used in applications such as text classification, document analysis, and sentiment analysis. The fourth category is neural network. Inspired by the structure of the human brain, neural network consists of interconnected layers of artificial neurons that learn patterns from data. They are capable of modeling highly complex relationships and can automatically learn useful representation from large datasets. As a result, neural networks have become the foundation of many modern artificial intelligence systems. And the final category is transformer-based models such as BERT and Roberta. These models have gained significant attention, particularly in natural language processing tasks. So, unlike traditional approaches, transformers can capture contextual information within text, allowing them to better understand the meaning of words and sentences based on their surrounding context. This capability has led to major improvement in tasks, such as text classification, question answering, and language understanding. In the end, each algorithm category has its own strengths, limitations, and ideal use cases. Therefore, selecting the most appropriate algorithm depends on the problem being solved, the characteristics of the data, and the desired balance between interpretability, predict performance, and computational efficiency. Next, once a supervised learning model has been trained, it is important to evaluate how well it performs on unseen data. A model that performs well during training is not necessarily effective in real-world situations, so evaluation helps us determine whether the model can make reliable prediction on the new data. The evaluation method that we use depends on the type of task being solved. So for classification tasks, some of the most commonly used evaluation metrics are accuracy, precision, recall, and F1 score. Accuracy measures the proportion of predictions that are correct overall. So while accuracy provides a useful general overview, it may not always be sufficient, especially when dealing with imbalanced datasets. Therefore, to gain deeper insight into model performance, we often use precision and recall. Precision measures how many of the intents predicted as positive are actually correct, while recall measures how many of the actual positive intents are successfully identified by the model. Because there is often a trade-off between precision and recall, the F1 score is commonly used to combine both metrics into a single value. This makes it particularly useful when balancing false positive and false negative is important. And for regression tasks, the focus shifts from classification correctness to prediction error. Instead of measuring whether prediction belongs to the correct category, regression metrics evaluate how close the predict value is to the actual value. Common metrics that use include mean absolute error or MAE, mean squared error or MSE, and root mean squared error or RMSE. This metric quantify the difference between predict and actual value that helping us assess the accuracy of numerical predictions. In summary, classification metric evaluate the quality of category predictions, while regression metric evaluate the magnitude of prediction errors. Selecting the appropriate evaluation metric is essential because it allows us to measure model performance accurately and make informed decisions when comparing different models. Next, Kanisa will explain the next part of our presentation. Thank you.
Now, I would like to explain Learning Outcomes 5, which is to recognize real-world application of supervised learning, particularly in complaint classification from social media. Supervised learning is widely used across many industries to automate prediction and decision-making tasks. Common applications include spam detection, fraud detection, medical diagnosis, recommendation systems, and sentiment analysis. To illustrate a real-world application, consider a public transportation provider that receives thousands of customer complaints through social media platforms every day. Without supervised learning, these complaints typically need to be reviewed and categorized manually. This process can be time-consuming, difficult to monitor, and may delay response to customer concerns. By applying supervised learning, complaints can be automatically classified into predefined categories such as delays, overcrowding, service quality, safety, and cleanliness. This enables organizations to process large volumes of feedback more efficiently and consistently. The classified results can then be summarized in a dashboard, allowing operators to identify recurring issues, monitor complaint trends, and prioritize improvement efforts. As a result, issues can be identified more quickly, response times can be improved, resources can be allocated more effectively, and service improvements can be guided by data-driven insight. This example demonstrates how supervised learning can transform large volumes of unstructured social media data into actionable information that supports more efficient operation and better decision-making. In conclusion, we learned the supervised learning is the foundation of many AI systems we use daily. From understanding how labeled data trains model to the algorithms that power classification text and the metrics we use to measure success. All of this comes together in real application like automatically categorize public complaints from social media. That is the end of our presentation. We hope information we have shared has provided a clear understanding of the topic. Thank you for your attention.